Good US morning and Norwegian afternoon. My name is Kazimbe Kennedy, and I'll be presenting our paper on misconception-based peer feedback, a pedagogical technique for reducing misconceptions. And along with Aubrey and Eileen, we're all from Clemson University in the US. So the overall problem is how to leverage our knowledge of misconceptions for improved pedagogy, particularly in the context of rising enrollments. Students come into classes with firmly held beliefs, but knowing the misconceptions they have is beneficial for the development of pedagogical content knowledge. So I've done work to identify student misconceptions in their CS1 and 2 courses with the goals of addressing them through studies such as my What Are You Thinking, which was a conceptual assessment survey that I developed which built on the ideas of concept inventories, and also Coding in the Wild, which had students come in and try and reverse engineer an executable while performing a think aloud protocol to know what they were thinking while trying to code it. These studies have shown a consistent value of feedback, particularly feedback that is given in a timely and a quality manner. So it's more than just yes or no, correct or incorrect. It actually helps students move along further. And so this made me think, how can we best use this element of feedback? That led to the idea of active learning, which is another one of my research areas. Combining feedback and active learning brought the development of this misconception-based peer feedback, or MBF. The P is silent. So what's this recipe? If you wanted to kind of create MBF, the first ingredient is to identify those misconceptions. You can use things like concept inventories, conceptual assessment surveys, think aloud. The important part is you want to have qualitative data to actually know and have insight into what the students are thinking. The second step is to have a lab assignment, which allows students to exercise those concepts. So for this study, it was based on my Coding in the Wild study. There was a flip program. Essentially, students had to write a code that would send two integers into a function, and if one was positive and one was negative, it would flip them so that the positive would be negative and the negative would be positive. And so then, kind of, I call it the secret sauce, are these structured prompts. So they were developed to structure conversation and elicit responses that address misconceptions with proper terminology. The development of these prompts, it was a key part of my thesis, but not addressed as in depth in the scope of this paper. So then what was the methodology for this study? So on day one, everyone worked individually, starting off taking an explain your reasoning EYR pretest on those concepts that exhibit the misconceptions. And then after that, students would work for 30 minutes independently to attempt to implement that flip lab that I just described. On the second day of the lab, the students were split into pairs and randomly assigned either partner A, which is feedback provider, or partner B, which is feedback receiver. So the provider has index cards and instructions to get feedback, and then B, the receiver has their code open and they can edit that code based on the feedback. So the different lab sections were broken up into either misconception-based feedback, which is the treatment group, or human autograder, which I'll talk about in a second. So the MBF group, they have discussions about potential misconceptions through the use of these structured prompts, whereas the HAG groups, they just get the confirmation feedback. So the partner A feedback provider would just say, is your code giving the correct output? And if it's not, this is what the correct output should be. So then everyone then split up again individually and took and explain your reasoning post-test, where the questions align. There's a one-to-one mapping from the pre-test. Conceptually, they just have different variable and function names as well as values. So the MBF group, this is the treatment group. We had physical index cards, and it was broken into 5 different categories based on ways that the students could have implemented the program or things that they would want to consider for the implementation. So here's an example from the pointers category where you would have this discussion about, did you use pass by reference or pass by value? And then the students would also get to discuss what's the difference between the two, and that would help them address some of their misconceptions. Now, the autograder group, we wanted to work with a control that's being commonly used within computer science courses, particularly with rising enrollments. So we decided on autograders, which usually provide that confirmation feedback. But then to control for the medium, we used human autograders. By controlling for the medium, this was because the misconception-based feedback pairs were receiving their feedback from a human. So we had the autograder group also receive their feedback from a human. So as you can see on the left side, you start off with a test case. The feedback provider would have on the front of their index card enter these two integers, and then on the back, it would give that expected output. And partner A would tell partner B whether their code was working correctly, essentially. So what was the data that we collected? First, there were the misconception frequency counts presented by the count from the children's program Sesame Street. These were based on those explain your reasoning pre and post test that the students took. And so these counts, we did closed coding on the why, the kind of reasoning, the R of the explain your reasoning that students gave. And then we also collected video and audio data, which turned into transcripts of the partners participating in either the treatment or the control group. In terms of analysis, so there were two phases. For the focus of this paper, it was the sequential exploratory, but then there was also a concurrent nested phase. It's mixed methods. So for sequential exploratory, essentially that's when your qualitative, which in our case were the misconception counts using closed coding, happens before the quantitative, and the qualitative takes precedence. And then concurrent, that's when qualitative and quantitative happen together. In our case, qualitative still takes precedence. So that's after the scope of this paper, perform thematic analysis and more statistical analyses. So yes, so then what do some of these quantitative outcomes look like? So essentially, the null hypothesis would be that you would have the same number of misconceptions on the pretest as you did on the post-test, regardless of treatment or control. So nothing really did anything. Whereas the alternative would say that you would have more misconceptions on the pretest than on the post-test, meaning that your misconceptions were reduced, and particularly you'd hope to see that with that MBF group. So as you can see, the bolded numbers are statistically significant. So the MBF group overall did have statistically significant reduction of misconceptions, but then even particularly for questions 6 and 7 showed a lot of interest. These questions related to pass by reference versus pass by value and using pointers. And you can see not only was there statistical significance in terms of improving from pre to post test, but when we ran t-test to compare the MBF to the HAG group, the MBF statistically significantly outperformed the HAG group. And this was also corroborated by performing ANOVAs after the scoping end of this paper. So here's an example of one of the post-test explain your reasoning questions. This example of code that uses both pass by reference and pass by value. So one of the variables ends up being manipulated by the time function g ends, whereas the other variable is only changed in the scope of function g because a copy is passed. So I'm going to kind of walk through that. You see on line 7, it starts where grape is declared with a value of -4 and an address associated with it. Then on line 8, the same thing happens for banana. You then move to line 9, where you see the address of grape being passed into function g by reference, and the value of banana is passed. So the function has an A pointer that is pointing to grape. Line 2 shows how grape's value is changed by dereferencing that A pointer and manipulating it. And then line 3 shows how B is only changed within the scope of function G since it's passed by value. So only a copy of banana's value of 6 goes into the function. By the end, you see that grape's value has changed while bananas has not. So here is the same code, just in a different format. I'm going to walk through an example of one of the MBF groups, the treatment groups. So it starts with, on the pretest, student says no return for function G to affect the values. So they had that neither grape nor banana changed in terms of their answer and an incorrect answer, as well as reasoning along with it. Then during the intervention, the students are talking about pointers and what they do. And they say, well, they're just kind of pointing to kind of the address where the data is stored. And then when they get to the post-test, the same student now says, the function G changes grape by using pass by reference and pointers. It changes banana by pass by value. So you can't see the actual answers they put, but they did also answer the question correctly now with having grape change and banana not change. There was a little language mix up. They say it changes banana, even though banana doesn't change, but they did have the correct answer of banana not changing. And now they're speaking of pass by reference and pointers and all of those things. So, what are some of the outcomes overall? There's evidence of improved learning outcomes with MBF, particularly in the sense of pass by reference versus pass by value and pointers. The potential for using this technique in resource constrained environments, using partners and peers that are already within the class doesn't take much to implement. And then also, both the feedback provider and the receiver can receive benefits. Limitations, so this human autograder, it does control for feedback medium, but it's not as realistic as autograder. So replicating the study with an actual autograder would be interesting to see. Also, selection threat, although we did completely randomize the sections in which treatment or control you did receive, the individual students were not randomized. Um, and then there's also testing, because the students were aware of the pretest and the purpose of the study. They could have gone between the days of the intervention and done some reviewing, but all students had the same opportunity to do this. And then lastly, power, sample size. This was done with 76 students. Um, and so having more students could allow for additional things to be found or observed to be significant. For future work, so this technique was a part of my dissertation, and so the motivation for that dissertation was to address retention in computer science for underrepresented minorities. I actually went to Morehouse College, which is pictured here, which is a historically Black college in the U.S. So I'd want to, and continuing to work on replicating this study, or determining other ways to address misconceptions at minority serving institutions such as historically Black colleges and universities. So thank you, and look forward to questions.